ISBM, your first step towards right career.
Let's start with the same queuing model what we have learned yesterday to continue the queuing model. Starting from slide number 31, illustrate of transient and steady state condition. So you can see over here the NT and ENT, which is shown in this graph, the number of customer in the system at the time t, which is nothing but NT, it's showing the zigzag manner, and the red line, which is showing the ENT curve, which is represent the expected number of customer in the system. So you can see the difference. You can see the difference over here. The NT and ENT, the number of customers in the system, and represent the expected number of customer in the system. So this is the graph between. It started with the same, the 10, and moving the NT graph, I mean the NT curve, the number of customer in the system. It may vary. Why it is shown up and down? Because it may vary. Sometimes customer will be more and sometimes customer will be less. So it depends. So that's why it is in zigzag manner, and it is up and down. ENT is represent the expected number of a customer. It is expectation. ENT is nothing but a E. Just keep in mind E stands for expectation. So expected number of a customer. So it maybe go up, maybe go down, maybe go flat. It is expected. The next, it is notation for steady state analysis. Then this is we can say that we have the notation for steady state analysis. The probability that there are exactly n customers or job in the system. The L is the expected number of customers in the system. LQ stands for expected number of customers in the queue. W is expected time a job spent in the system, and WQ is nothing but expected time a job spent in a queue. So these are the notations for each and every value what we can see or what we can check over here. Then birth and death process, I think we have completed this. Now we have to start from here. Assumption a basic queuing process. Infinite calling population. Infinite calling population is independent between arrivals. There is no dependency between the arrivals. The arrival process in a poison with an expected arrival rate lambda, which is independent of the number of customers currently in the system. The queue configuration is a single queue with the possibly infinite length. No reneging or barking. The queue discipline is FIFO, what I have told you about, first in first out. The service mechanism consists of a single server with exponentially distributed service time. Mu is equal to expected service rate when the server is busy. Then ER of a county hospital. It's an example. So situation, suppose patient arrive according to the poison process with intensity lambda. The time between the arrival and expected mu distributed. The service time, I'm going to say the doctor examination and treatment time for the patient, which is nothing but a service time of the doctor, follows an exponential distribution mean, which is 1 by mu, which is expected distribution mu, which is called mu. So service time is nothing but just like a patient has arrived in a clinic, so doctor will check that particular patient. So from checking to till the doctor has leave that patient, so the time between these, when the customer, the patient has entered into the clinic and the doctor has started to checking the patient from that time, and when the doctor has released the patient till that time, this is the time. So this is the service time in which doctor will serve the patient like that. So this is all the service time. The ER can